Hello everybody, this is Matthew Powers, and today we're going to talk about dealing with null and Spark. This video is generally going to follow this Munging Data blog post of dealing with null and Spark, so I will link to that in the description below, but we will spend most of our time in this video in this Databricks notebook. So null can be quite a messy issue in Spark, especially when it comes to user-defined functions. So in this video, we're going to talk about all of that messiness. Before we get to all the disgusting UDF edge cases, we will talk about how Spark uses null with some of its native functions. We'll also chat about the nullable column property, which is basically allowing null in certain columns and not allowing it in others. We'll talk about how native Spark can be used to avoid weird null edge case logic, and that's been kind of my happy medium with Spark. I used to suffer with a lot of null pointer exceptions. I figured out how to use Spark native functions to avoid that suffering. But sometimes you need UDFs, so we will go through all of the messy UDF null logic details. Cool. So let's start out with what is null. So null means that a value is unknown, missing, or irrelevant. So null in programming languages is kind of different from null in relational databases. The null best practices with Spark are kind of more aligned with the null best practices of a relational database. Just to get that out of the way. All right, so let's import some stuff. And let's take a look at this little CSV data we're going to be working with. I'll open it up here so it's easier to see. So this is just a little CSV file. It has a name, it has country, and it has zip code. So 3 columns. It has 3 rows of data. So the first row has the name, country, and zip code all populated. The second row has the name and the country, but it does not have the zip code. And the third row has this empty string for the name. So we'll see how that gets interpreted by Spark. It has nothing for the country, and it has a zip code. So remember, going back to our definition of null, it is something that is unknown, missing, or irrelevant. So we can kind of see that this zip code is missing. This name is arguably unknown. And this country for this third row of data is missing. All right, so let's read in that file to a Spark data frame. So I already uploaded this file to Databricks. We're using Spark read option. We're setting the header to true because if we look at our CSV data, we do have this header row. And we're using the CSV method with the path to our data. All right, so let's take a look at that. See what we get. Cool. So we can see for our first row, all of the data was populated, so there's no null values. For our second row, we remember the zip code was missing, so that is null. And for our third row, we can see this empty string is interpreted as null, as it should be. And the country is also interpreted as null. So cool. That's just a little introduction to null. We can see Spark is using null by default in a lot of their methods, and it's not just the CSV method. Obviously, Spark is using null by default for tons of stuff, including database joins and tons of stuff. All right, cool. So now let's look at the nullable property. So in this little code snippet right here, we're going to be creating a data frame. So what we need to do is define a data frame schema. We need to define some data, and then we need to use this little chunk of code to create the data frame. I'm not going to go into complete depth on all of this creating data frame stuff, but I will create another video that kind of goes into depth in this code. For purposes of this video, we're just kind of really interested in, well, actually, let's display the data frame, and then we'll kind of see what we created, and then kind of work our way backwards. So what we're creating here is a data frame with 2 columns. The first column is name. The second column is age. We can see that this first column is a string type, and this false is the nullable property. So what does a nullable property mean? So so we can think of a struct field as basically a column in a data frame. And each column is going to have a name, it's going to have a type, and then it's going to have a nullable property. And the nullable property means, can this column take null values? So in this case, we're saying that the name column cannot take false null values, but the age column can take null values. So everything's kosher here, and there's no errors because this age column has a null value, but we're saying that's okay. And there's no null values in the name column, so no errors were thrown. Now, if we tried to create one of these names to be null, then we would get an error. So let's just do that. So it's saying the 0th field name of input row cannot be null. Now that's kind of a weird error, but it would be nice if it was talking about the nullable flag or something like that. But just good to know when you see that error, you'll be able to identify it in the future. All right, cool. Let's keep moving on. I don't want to make this video too long, although it probably will be very long. So that was just an example of that. Let's see what we have here. All right, so let's create a little bit of data, a little data frame, the numbers df, that we'll be able to play around with. So here we're creating a data frame. It has a single column. The column is called number. It is typed as an integer, and it is the nullable flag is set to true, so that means that the number column can take null values. So we create some data in this data frame. We have 1, 8, 12, and null. We create this data frame, no problem. Cool. So here's our little data frame number. We have 1, 8, 12, and null. All right, cool. So let's say we want to add a column that is even. And we want the is even column to return true if the number's even. We want it to return false if the number's odd. And we want it to return null if the number is null. And that returning null when the input is null is a very, very important lesson for us to learn here. So whenever the input is null, our function should always return null. And that's what Spark does. Now, when we use native Spark, we can see here we don't have any custom logic to handle the null case. So we're using this modulo operator is defined in the Spark column class. So now this is kind of weird. So this number thing here is a column object, and then this operator is defined in the column class, and that's when we can use it. I know that there's a modulo operator in Scala too, but this is not Scala. This is the Spark modulo operator. So now this is really nice that when we're using native Spark, we never have to write custom null logic. It just kind of always works. And that's kind of the main takeaway from this video for all of you viewers, is that always use native Spark whenever possible and avoid UDFs, because when you use UDFs, you need to deal with messy null logic. So the rest of this video is going to be chatting about all these UDF null pointer exceptions and all the messy null logic that we need to write to deal with null when it comes to UDFs. So feel free to skip the rest of the video if you want to just use native Spark and never think about UDFs. Unfortunately, sometimes native Spark doesn't cut it, and you need to revert to UDFs, so maybe watch the end of the video. I don't know. Up to you. No pressure. No pressure. Cool. So now let's dive into this UDF messiness. So when we're creating a user-defined function, basically what we do is we write a regular Scala function, right? So this code right here it's defined as it's a function. It's called isEvenSimple. It takes an integer argument, it returns a Boolean, and it runs a bit of code. Now, in order to run this Scala code in Spark, we need to create a user-defined function, or a UDF for short. So in order to define a UDF, you need to use this UDF. I think that's a function. Yes, that is a function, because they're using generics. So when you define the UDF, you first need to specify, the first argument is what's returned, and then you follow by the inputs of the function. Now this kind of looks backwards, just as an FYI. And then you just need to pass in the function as the argument. So that's how you define this UDF. And now we can use this UDF in a Spark analysis. So let's indent this properly. So here we have, we're using our same numbers df from before. So we have this 1, 8, 12, and null. And we are going to run this is even simple UDF. So let's take a look. All right, wham, wham. This errored out. This sucks. Okay, so and I think what also sucks about this is the error message, because it's like, what is this? So it's saying Spark exception, failed to execute user-defined function, and it's complaining about that. Okay, and then we need to kind of look down here and figure out what the caused by is, and it's saying caused by Java lang null pointer exception. Okay. So this is a weird error message. When you start getting these, you will be confused. I was certainly perplexed at the start. So when you're getting these error messages, you just need to know that, okay, my UDF is not handling null input gracefully. So before we move on, we're going to fix this, but I just wanted to show you all about how this is a regular Scala function. So let's open up Scala. Let's do paste. All right. So now we've defined this is even simple function. And let's give it 8. That returns true. Let's give it 1. That returns false. Let's give it null. That gives us Java lang null pointer exception. Okay, so now we can kind of see where this null pointer exception is coming from, right? We are passing null into is even simple, and that returns this null pointer exception. Okay, so let's fix that. So let's use our same, we actually don't need to define this again. So we already have defined this is even simple. So let's invoke this function just a little differently. And this is kind of a great example of a hack and something you probably shouldn't do. Maybe I shouldn't be showing everybody hacks, but don't finish the video after this hack. You should look at it to find out how to do it the right way. So anyways, so the hack in this case is we're going to use this when. We're going to say when the number is not null, then we can execute our function. Let's actually, I don't really like how I'm doing this. It makes it hard to read. All right. So when, otherwise, so when our number is not null, then we do is even simple UDF. Okay, so we know is even simple UDF is working as long as the number is not null. It's only an issue when the number is null. So is not null is coming in handy here. So we only execute it, this UDF, when it's not null, and that'll get us our answer. Otherwise, we're just going to return null. So this is a hack. This is ugly, but at least it works. Let's look at some better ways of doing this. So let's try to update our Scala function to kind of handle null logic. So here we have this is even bad function, and we're saying, well, if the number is null, then return false. Otherwise, return the regular modulo operator function, true or false. Now, the reason why this sucks, and we can run this and it's going to work, so we finally are handling the null input, right? But the reason why this is bad is because we don't want null to be considered, is false, is even to be false for null input, because null is not true or false. Null, it doesn't make any sense if null is even or not even. It just doesn't even, null is not even a number. So this is bad. It kind of gets us in the right direction because we're not having to use the when stuff anymore and do that hack, but it's bad because it's wrong. So and it's also bad from a Scala style perspective. You're never supposed to be referring to null explicitly. So one thing that's kind of interesting is we actually can't do this. This doesn't work. So the reason we can't do that is because this is a function that returns a Boolean value. So null is not a Boolean value. So what was that? False. Null is not a Boolean value, so Scala doesn't let you write a function that's going to return null when you're in your type signature, you're saying it's returning a Boolean. Okay, so let's stop looking at this horrible code. Let's look at something that's giving us a better output, but still kind of bad coding style. Okay, so let's look at this function. It's called isEvenBetter. So now you need to start knowing a little bit about how option, none, and sum work. So remember in the function we just looked at, right? We couldn't return null. Now what Scala has done is created this notion of option, none, and sum. So you can create a function that returns an option value. And this is an option Boolean. So when you say your function is returning an option Boolean, it can return this sum value, which is kind of like, we can think about this as like the returning of the Boolean value. And we can think about this as returning null. So here we can see that our UDF signature needs to be a bit different, right? So we need to return this option Boolean. Remember, the first argument of the UDF always corresponds with what's being returned, and the second one are the arguments of the function. And we can see that this is working properly, right? 1 is not even, 8 and 12 are even, and then we're getting null for is even, which is great. So this is right, at least. This doesn't require us to do the when hack. So we're heading in the right direction, but we still have this bad Scala style thing where we're referring to null directly, which is not something we should do. So let's take a look at the final kind of best way of doing this. So here we have our isEven option function. So here we have a function that's taking an integer, it's returning an option Boolean, and what we're going to do is we're going to take that n, we're going to convert it to an option value, so option n, and then we're going to do get or else return null. So this is kind of Scala's weirdness, but basically if this is something that can be gotten and converted to like a value, like let's say the input is 4, then num is going to be like 4, but otherwise it's going to return none. So actually let's just do this. Let's see this in the console. It's going to be the easiest way to visualize this. I feel like I'm doing a pretty bad job explaining this. Okay, get or else. Let's see, none. Okay, so if we're passing in 3 here, this is going to return 3. If we pass in null here, that's going to return none. So this is kind of how and this return value is going to aggressively return none. So basically we're going to say if this is returning if this is a real integer value, then we can run our code. Otherwise, we're going to return none. And when you return none, that's going to be reflected in, once it's run through the UDF, none is returned as null. So I feel like I did a really bad job explaining that. I will probably do another video on option, sum, and none. But at the very least, we can see that this is working and this is the best solution. So here we can see we had to do a little bit of a hack. We take in an integer and we convert it to this option value, right? So option 4 converts it to this like sum value. Now, something Scala lets you do is it lets you pass in these option values. So why couldn't we just pass in this option integer as opposed to passing in an integer? Now, unfortunately, this doesn't work because this is another weird thing with Scala, with Spark. So UDFs can return option values, but they can't take option values. So we can run this. We can see it's not going to work. And the error message is failed to execute user-defined function. And let's see the caused by the class cast exception. Java lang integer cannot be cast to Scala option. So if you mess around with UDFs enough, you will try to make this work, and it will not. And you will just need to realize that you need to pass in regular values as arguments to your Scala functions, and then use the option n in your function body to get this stuff to work. Okay, so I've just babbled on for so long I've confused myself, but let's do a quick recap of all the stuff we've covered and our next steps. So pretty much, and this is what I've done in my Scala, in my Spark code, I pretty much just always use native Spark. If you always use native Spark, you don't have null pointer exceptions, and you don't have to write a lot of custom null logic. I used to face a lot of null pointer exceptions. I used to have to be very militant about making sure I tested every permutation of null in my test suites when I was using a lot of UDFs. And by quitting UDFs, I kind of just don't really have to deal with null pointer exceptions anymore. But with that being said, right, we all know that sometimes UDFs are needed because native Spark isn't sufficient. And if you use a UDF, make sure to follow the best practices outlined in this post for handling null input, and make sure to really test every permutation of null so that when you deploy your code to production, you're not getting null pointer exceptions. So I hope everybody found this video useful, and I'll look forward to seeing you in the next video. Bye-bye.